Hello, here we have a new screencast lecture. Tonight we're going to talk about chemical changes. Last time we talked about physical changes, and we need to know what a physical property is. We need to know what physical changes are, and you should be able to define physical change. You should be able to define physical property, and you should be able to give at least a couple examples of a physical change. One of the things you should remember is that physical changes, the appearance of the items will change. They'll look different. Like if you have a glass and you break the glass, the broken glass and the non-broken glass definitely look different. They have different properties. However, they are still the same thing. They're still glass. If you have a block of ice and the block of ice melts, it has different properties than the puddle of water does. So you have the solid ice is solid, it's cold, and when it melts, it's going to be liquid, and the temperature will not be as cold. So it's the same stuff, it's still water. However, today we're talking about chemical properties. Chemical properties, the definition, first of all, is a characteristic that cannot be observed without changing the substance. So the substance itself would have to be changed to observe a chemical property. An example of a chemical property is that it is able to burn. Here's a video clip. What are some things that you can think of that can burn? Or in other words, what are some things you can think of that are flammable? And oddly enough, the word inflammable means burning too. It means the same thing as flammable. Here are some examples: wood, coal, hydrogen gas, oil, polyester, methane gas, like natural gas like we've used in the classroom. Here is a clip. The ability to rust is a chemical property. So when iron oxidizes to iron oxide, that is a chemical change. Iron and iron oxide are very different. They have different properties. They're different colors. The iron is much stronger, and the rust is very brittle. You can crumple it up with your fingers. And on a molecular level, it's a completely different substance. Iron and iron oxide are different substances. Here is a video clip. The ability to react with acid is another example of a chemical property. When certain things come into contact with acid, there will be a reaction like limestone. So when limestone comes into contact with acid, it'll actually bubble up and release gas, in this case hydrogen gas, and this is hydrochloric acid. Certain items are able to react with acid, like certain plastics, certain metals, zinc, copper. Here's copper, and when it reacts with acid, it turns this weird green color. Some examples of chemical properties could be the ability to burn, the ability to rust, or that it will react with acid. Those are all chemical properties. That brings us to chemical changes. Chemical changes are defined as a change where the substance doesn't only look different, but the substance itself is different. It's a completely different substance. So again, if you think about water, you have H2O, you have solid water. At the end, you have liquid water. If it melts, that's still H2O. However, if you have water and you run electricity through it, you then have hydrogen gas and oxygen gas. They are two different substances. Here's the example we talked about before, iron. It's exposed to rain or air. After a while it rusts. And rust, iron oxide, is a different substance than iron. That's a chemical change. Another example of a chemical change could be silver. If it's exposed to ozone, the silver tarnishes, the silver experiences corrosion. It is a chemical change. So you see silver is a shiny silver metal. When it tarnishes, you get this nasty dark crud on the silver. Another example would be wood is exposed to oxygen, and when there's a spark, the wood can burn, and we no longer have wood. We have ash, we have carbon dioxide, a bunch of different gases, even carbon monoxide. It's a chemical change. Ash and soot and creosote, all that stuff is not the same as wood. We talked about electrolysis a little bit before. If we run electricity through water, we can actually separate H2O into hydrogen and oxygen gas. Completely different substances. Hydrogen gas and oxygen gas don't act anything like water at all. Clues. Now, to know if something is a chemical change versus a physical change, you could look for some clues. And some of those clues include a color change. That's usually a pretty good one, a pretty easy one to spot. So if you're roasting your marshmallow, you notice that the marshmallow changes color from the pretty white to this golden brown. That's an indication that a chemical change has occurred. Green leaves. Green leaves, over time, they lose their color. That is a chemical change. That's an indication there's a chemical change happening. Here is a video clip. If you've ever been injured during a sporting event, you may have used one of these. These are those chemical cold packs where you crunch them up, you break them up, and they get cold. And that is a clue that a chemical change may have occurred. If heat energy is absorbed, so in other words, it gets colder, and you don't really know why. It's not because the temperature outside got colder, you put it in the freezer or anything, but the reaction caused a loss of heat energy or loss of temperature. And the opposite way would be if heat energy is released. Like, for example, potassium acetate or de-icer, heat is released. Like if you've ever been on an airplane in the winter, you may have seen people spraying the wings to try to get the ice off of the aircraft. Here's a video clip showing sodium acetate in action. If you've ever made plaster of Paris, when you mix it together, it's kind of neat. It actually does start getting warm. That's a exothermic reaction. That is a sign that there is a chemical change happening. If you see light being produced by a reaction, that's a really good clue that a chemical change is occurring. Like, for example, when you see fireflies, their backsides glowing, there's a chemical change going on. Those chemical light sticks, you've probably played with those at Halloween and such. Those are really good examples of chemical changes. Fireworks. If there's a new odor produced, that could be a good sign that a chemical change has occurred. An example of that could be food rotting. I'm sure you've noticed some nasty, nasty smells. Your food has been rotting, like you left your lunch in your locker for several months. Mulch. If you've ever had mulch put down for the summer, and if you've ever had it just kind of sitting there on your driveway, you may have noticed that the pile of mulch actually starts getting kind of warm. When the mulch is rotting, there's actually some chemical changes, and it's actually exothermic. It actually does release heat and gets warm. It can actually lead to fires, like, for example, mulch fires, and they can actually just start all by themselves. You don't have to throw a match on them or anything. There could be enough heat being produced that a fire could start. Here's a video clip about that.
This has been a pile we've been monitoring and watching ourselves, and apparently around noon was when I got alerted that the guys thought they should call the fire department because it was blazing. And then from there it must have happened very quickly, which is the problem when you have wood waste and you have high wind. We have this happen occasionally, and that's why we have our own little fire truck and our hydrant right here across from our property, because our piles are decomposing with the tree bark, and they get a hot spot in the center of the pile, and then when our loader buckets come in to take mulch out to process, wind can hit that hot spot and ignite it.
If gas is released, so if gas is released, you might see bubbles occurring. Like, for example, when you put vinegar and baking soda together, there are bubbles being released when you do that. You may have done like the old classic volcano, where you take baking soda and add vinegar to it and make it have a volcanic eruption. If you've ever baked bread before, you may have noticed that the bread dough is small at first, and then as it bakes, it starts to rise. Now, that's caused by the yeast. Yeast releases gas in reaction, and definitely sometimes there are releases of gas in certain circumstances. And a lot of times that release of gas also accompanies a change in odor, you may have noticed. And here you see these air bubbles being produced by the yeast as the bread dough is being prepared and rises. You may have noticed Swiss cheese. There are the big holes in the Swiss cheese. Some people say it's because of mice crawling through it. It's because of gases being released, and there's a chemical change when the cheese is being made. Here's a clip of a chemical change showing some gases being released.
All right, in 3, 2, 1. So I'm going to do a dump, and let's take a step back.
Cheers.
Very nice. So as we can see, it's releasing that oxygen gas, and it's slowly building, and we have this reaction taking place a lot quicker than what would normally take 6 months is now taking 6 seconds.
Thus our elephant toothpaste.
Yes, exactly.
And it's going to keep going.
It is going to keep going, and if we take a step forward, it feels a little bit warm because it's actually releasing heat in something called an exothermic reaction. Wowee. So this weekend we're hosting You Be the Chemist. We're actually closed on Sunday, unfortunately, but
so some holiday hours then, closed
holiday
on
hours,
Sunday.
exactly. But we'll be reopened this Monday.
And you guys love science and making a mess,
Oh,
just
we
like
do.
you did in our studio this morning. We appreciate you coming in, and of course, you guys just down the street at the Imagination Station. Check.
All right, here's a quick review for you. Hopefully you should be able to answer these. So, physical or chemical changes. You have sugar changing to alcohol. You have a completely different substance, so that would be chemical. Sugar and alcohol, they are very different. Iron rusting. So you have iron and then you have rust. That is a chemical change. That is two different substances. Please have a good day. If you have alcohol and the alcohol vaporizes, so let's say you have some rubbing alcohol, you pour it on your hand, and your hand feels kind of cold, and the alcohol vaporizes, evaporates off your hand, that would be a physical change because the liquid alcohol and the alcohol in gaseous state are still the same substance on a molecular level. paper can burn. You take a piece of paper, you light it, you burn it. That is definitely a chemical change. The paper and the ashes and all that kind of stuff left over are very different substances. Sugar dissolving, that's a tricky one. If you have sugar, you have a white powder, you put it in the water, stir it up, it dissolves into the liquid. However, it's still sugar and water. So that's a physical change. It's not a chemical change. Tearing up a piece of paper, this one should be a little bit easier. You have a piece of paper, you tear it up. It is now a bunch of little pieces of paper, but it's still paper. So that is a physical change. Hopefully you did pretty well with those. Now, digesting food, that's kind of a tricky one, because if you think about digesting your food, you eat a sandwich. Is that a physical, is that a chemical change? Well, before you eat the sandwich, and then after you digest it, certainly looks very different. A sandwich, and after you're done digesting that sandwich, it looks very, very different. Definitely a change in color, definitely a change in odor and things like that. Gross. But there are physical and chemical components to digestion of food, if you think about it. So, like, for example, physical changes. Think about a physical change. If you have that sandwich and you cut it into slices, that's obviously a physical change. But what about part of your digestion system? What it would be similar to cutting up the sandwich? Well, if you think about it, that would be kind of like biting. So digestion includes physical and chemical changes. Chewing would be breaking those big pieces of sandwich into smaller pieces. That is one example of a physical change in our digestion process. Another example would be swallowing. So when your esophagus pushes food down into your stomach, that would be an example of physical change. And the fancy sciencey word for that is peristalsis. And throwing it up, that would be called reverse peristalsis. And that's when the opposite direction goes from your stomach up back into your mouth. And here is a video clip showing an X-ray of somebody swallowing. This is pretty neat. Okay, physical, hi again. Examples of chemical change in your digestion process. Starting right at the very beginning again when you're chewing. Think about the saliva in your mouth. That saliva doesn't just moisten the food, which is important. That's more of a mechanical or physical process, so it helps it slide down your throat. But it also does start actual digestion. So the saliva in your mouth will start breaking down starches, and you'll start getting your food actually starting to digest. More obvious would be like your stomach acid. You may have heard of like acid stomach or acid reflux. That if you've ever thrown up before, you kind of had that awful taste, that acidic taste in your mouth. That would be the stomach acid. That would be the stomach acid coming back, and it is actual acid. It's hydrochloric acid, and it's there to break down chemically proteins. Well, that's all we have for tonight. Hope you enjoyed it, and we'll see you next time. See ya.
Take care, kids. Bye, and have a really good night.